Many of you would know that I am absolutely crazy about 6 meters, and improving the receive performance of my station is the number one thing to help me to work all of the DX on 6. Well, I came across a picture a little while ago which piqued my interest in using a cheap SDR in my own station. Now, in this image you can see on the screen, it shows the entire 6 meter band being received all at once on nothing more than a cheap $35 US NULEC RTL SDR dongle. This is about as cheap as an SDR as you can actually buy. Now, this is being used not as a PAN adapter, but as an actual receiver. In that image, you can see the CW and SSB signals. They're going there to a pair of speakers, and all 5 WSJT frequencies being decoded there are going to individual instances of WSJT or JTDX, and they're decoding all at once. Not only that, but you can also have up to 24 receivers all active at once, so you can have multiple different frequencies all running. And the computer really is nothing special. Now, to run this, all that's required is a basic nut, basically something that's got a little bit of grunt that can run Windows is basically all that you need. I came across a picture online from N0KK, and he showed his IC7610 and his AirSpy HF Plus running on SDR console with a side-by-side comparison off the same antenna trying to receive the same station. Now, you can see there in that image that it's very hard to actually see that on the 7610. In fact, it's almost impossible to see that on the waterfall. Now, this was on 15 meters. If you have a look off to the very right there, that is SDR console decoding the same station, and you can almost see the individual dots and dashes. So not only could you hear it, but you could also decode the CW by eye. Now, granted, that was not on one of these. That was not using an AirSpy Mini. That was using a HF Plus Discovery, which is regarded as one of the best HD SDRs out there, along with the RSPDX R2, which is from SDR Play. But it got me curious as to whether I could repeat what he did with my own 7610 and the bottom of the range AirSpy RTL. So since then, I've also got a couple of others. I've got the NULEC, and also did experiment with an RSP1A as well. Now, there's two main ways that you can set up a dual receive system. You can either use an IF tap or an SDR switch. And I've not really been a big fan of an IF tap because you're allowing your radio to process the signal before it gets to your SDR. And also in some setups, your bandwidth, it can be a little bit limited. On my IC7610, it has an IQ out, so I can pipe that into an SDR software, but I'm limited to HD SDR because that's the only one that it supports. So I came across also some results from HB9 VQQ. He showed the difference in whisper decodes between using an AirSpy HF Plus on the IF tap of his FT450D and another HF Plus straight from an SDR switch. So one of these SDRSwitch.com SDR switches. Now, the SDR switch allows the SDR to see the raw RF signal, which is unaltered, basically. It's just another receiver. And you can see that his results seem to show a clear advantage to using an SDR switch over an IF tap. Plus, it's much more easier for us to install one of these rather than opening up our radios and soldering in an IF tap or a PAN adapter. Now, HB9VQQ, he's been doing lots of testing on different configurations. He includes comparing an AirSpy HF Plus against his Flex 6600, again using an SDR switch. The HF Plus, the AirSpy, had 20% more decodes over a 96-hour period than his Flex 6600, which is pretty surprising, really. But the difference between two identical SDR receivers, one through an IF tap and the other through an SDR switch, were night and day. And you can see that there on this graph that shows the decodes between the two. So speaking of both those two results there from N0KK and HB9VQQ, they both run one of these, an SDR switch by N2EME Paul at SDRSwitch.com. Now, these are not the cheapest SDR switches on the market. There are many others on YouTube. You can see using cheap SDR switches from Amazon. There's others that don't really quote their specifications. But what I'm going to show you is, and in some of my videos, you've also commented about how much loss do you get when you insert one of these through your system? Well, I could show you that it's actually very, very low. So N2EME comes from a VHF background. He's done a lot of EME stuff. He's part of a 10 gigahertz EME record between WA3LBI and VK7MO, and he knows that in the VHF world, every dB counts, so insertion loss definitely matters. Now, the SDRSwitch.com page shows the figures for each of the 4 models that they offer. This is the information here on the RX in, RX out. So 0 to 450 megahertz is this particular model. And you can see there at 3.5 megahertz, the insertion loss is really, really low, 0.035 dB. And we go all the way up to 450 megs. And of course, as we increase in frequency, so does our insertion loss to 0.166 of a dB. Now, there's also isolation figures as well there. Isolation is incredibly important with SDR switches, because you want to make sure that when you're transmitting through using your normal transceiver, that you're not going to get a lot of RF power going in and blowing up your SDR or your LNA. Now, insertion loss is a big one to discuss. Lots of hams don't understand this. According to the ARRL, in a review on the MFJ 1708 SDR switch, the MFJ has 19 dB insertion loss on 70 centimeters, as you can see there. That's the equivalent of listening to your home stereo at 100 and then turning it all the way down to 1. So some of you have commented that adding one of the cheap switches made your SDR deaf. Well, this is the reason why. Insertion loss along with isolation, these are the 2 main numbers you should look at when choosing your SDR switch. Now, incidentally, the SDR switch 0 to 450 meg range has an insertion loss under half a dB. They were designed for weak signal and DXing. Another thing to note there, look at the isolation transceiver to SDR port. At best, it's 17.3 dB at 14 megahertz on the MFJ. Now that means if you run 100 watts from your transmitter, you're going to get 1.86 watts coming down your SDR port. Now that's bad. Your SDR will go pop. Okay, now there's quite a bit going on here. I've got wires everywhere, but I'm going to show you exactly how I've connected this up. So starting off at the back here, there is power to the SDR switch. So that is simply 12 volts. So I've got a power pole here on the back. The next port here is a PTT port. So around the back there, we've got 12 volts PTT amp LNA. So I've got a PTT. So this runs off to a 5-pin DIN for my IC 7300. So one of these pins is a PTT or send. So what happens is that closes to ground. So when I transmit on the radio, it goes to ground, and that sends a PTT signal to this box, which then triggers the relays. The next port is an amp. I'm not running an amp, so I'm not going to cover that, but basically that is a signal output for your amp to switch your amp on and off. The next port is an LNA. Now, that is power. That is 12 volts power out. That goes down here to, I've got a little 12 volt to 5 volt adapter, and then that powers over USB this low noise amplifier. So that will turn on and off my LNA as my main radio transmits. So now we get to the business end, which is on the front. So on the right here rather, we've got our antenna port. So I've just had a adapter sitting on there, and we've got BNCs all on the front here too, BNCs for the connection in and out. So basically what would happen is I'd connect my antenna on in here, and in its normal situation in receiving, the signal would come in through the antenna, go through the relays inside, and then back out through this RX out. So we're coming in through the antenna, through the relays, through the RX out. Now I've got here a LNA. This is a TQP3M9037 LNA. This covers 0.1 of a megahertz to 6 gigahertz. This is available on AliExpress, and I think you can get it also on Amazon as well. These are extremely cheap. They're like less than $10. It's absolutely remarkable. Now, the main thing about this is that whilst you get heaps of gain out of this, you'll get 20 dB of gain using one of these little things. It has an extremely low noise figure. Some of you might be like, well, what's noise figure? What's gain? So a lot of the time when people are looking at amplifiers or low noise amplifiers, LNAs, they're only looking at the gain. The problem with doing that is that once you have signal coming in, if you amplify it up, eventually you get to a point where you're only amplifying noise. You can't get what you've already lost, basically, is the way to think about it. So you can't amplify a signal up any more than what it's already coming in. So eventually you're just going to be amplifying the noise. That's where noise figure comes in. Noise figure is a completely different concept altogether, and you want as low a noise figure as possible. The lower your noise figure, the better your receiver is going to receive. Now, in most cases, some receivers will have a high noise figure. So even some SDRs, I think one of the SDRs, the name escapes me now, I think it's one of the SDR Play ones, actually has extremely high noise figure on a lot of the frequencies that it receives, so it would benefit greatly having an LNA in the line. Now, the LNA, you would say, well, I should put this at the top of right next to my antenna, which is true, you could do that. However, everything that is before the LNA is all counted also towards the noise figure. Now, most of the time, coax is pretty cheap. We can get high quality coax, low loss coax. So by the time we come in through our antenna and through the insertion loss of this, which is extremely low, our noise figure shouldn't be any more than sort of like half a dB or maybe 1 dB at the most. So depending on the frequency, of course, that we're using. You could put an LNA up at the antenna, but more than likely, eventually you're going to pop it. And for the fact that this thing is only like $10, it's beneficial to be able to, if you blow up an LNA in your shack, then it's a lot easier to replace than if it's up the tower. So if you can invest in some low loss, high quality coax, and then pop your LNA further down in the chain, where ultimately this is the first thing in the receiver chain, so it's going to affect what your noise figure is for the rest of your setup, then you can easily replace it if that becomes an issue. And if it's in the middle of winter, you're going to benefit from being able to just replace this in the shack. So anyway, we go through our LNA, we get 20 dB of gain, which is way more than what we actually need. So what I'm doing is I'm coming out here with some coax and I'm going into this attenuator here. And you can see I've currently got that set on the 20 dB scale. I was playing around with this a little bit and I've set this up as 20, so we've got 20 dB of attenuation. Now the reason for that is because of our LNA, we've got way too much gain. We don't want to overdrive or overload our receiver because we can get unwanted things such as images, harmonics. We can get spurious reception. We can get issues, all sorts of issues in our receiver, and our receiver can end up being worse off. So what we've got is we've got the attenuator. Now I've got a two-way splitter here. This is a mini circuits, if that'll focus. I've got a mini circuits ZSC 2-1 plus. This is 0.1 to 400 megs. Now this will introduce a 3 dB loss using one of these splitters. Now what happens is we've got splitting off to my SDR here, and then the other side goes back into the SDR switch, which is ultimately going to go to our transceiver. Now 3 dB loss in here is not going to be a problem because we've got so much gain in our LNA. We can offset it here with our attenuator, so rather than 20 dB I can select 10 plus 6 is 16 plus 1, 17 dB. And we've now compensated for any loss that we've got here in the splitter. In either case, even if you don't have an LNA and you are running a splitter, it's only 3 dB. You're not likely to actually notice this. The 3 dB is not even, it's like half an S point or not even half an S point. So even if you do run this, you probably, without an LNA, you're still going to see the benefits. So we've got our SDR. This is my NULEC here on the other side. And then here on the other side of the power splitter, we come back and into the SDR switch. And then we've got our transceiver connects to the TX on the other side. So that's how the reception works when we're receiving, when this is powered off or when we're in normal operation mode. Now, When we transmit, what will happen is my radio, which will send a PTT signal into the SDR switch. And what will happen is then these two ports get bypassed. So our transmit signal will come up this port, it will go through the coaxial relays, get bypassed, and come straight back out the antenna port, so that we don't end up blowing up our LNA. No RF goes down and into here, no RF goes into here, so we're safe. And that's basically what the purpose is of the SDR switch. So it does look a little bit, wires all over the place, but once you figure out how it actually all integrates into your system, it's actually relatively simple and straightforward. Now, there's also two models of SDR switch. There's the 3 BNC SDR switch, which in its simplest form will allow you to transmit on your rig and listen on your receiver of your SDR. Now, incidentally, the 3 BNC switch can also be used for a separate TX-RX antenna setup for those of you who on HF want to use one antenna for transmitting and a quieter loop on the ground or beverage antenna for your receive. This is a great option for those that might have a high noise floor and you've got a great antenna for transmitting, but it's not so good for receive. Then you can use a loop or something like that to be able to separate that out. And the model that I have is the RX in, RX out. So this is the 4 BNC RX in, RX out version. Now, as with the 3 BNC SDR switch, it's available in both a 0 to 70 meg version and a 0 to 450 meg version. So if you only want HF, you can get the lower frequency version. The main difference between the 3 BNC SDR switch and the 4 BNC RX in, RX outs is that the RX in, RX out allows you, when using an optional two-way power divider, such as the ones available on eBay by Mini Circuits, to receive on both your rig and the SDR, or even multiple SDRs at the same time. So you saw the Mini Circuits splitter that I've got. Here's another one here that you can also get if you're not, if you can't find the one that I've got. This is a Mini Circuits ZF SC-2-2500-S Plus, big model numbers. But one of the things is that why is the splitter not built inside the SDR inside the SDR switch as it is with some other SDR switches on the market? Well, it's quite simple, because a two-way splitter introduces around a 3 dB loss, whilst a four-way splitter has around 7 dB loss. So by allowing you to choose an external splitter, not only allows you to control your losses, but allows you to customize your setup. So you can put in an LNA like I've got, or you can also put in a bandpass filter. And the RX in, RX out was originally designed to allow you to install LNAs in line. So the more about LNAs, as I mentioned, check out that page on Paul's website. Now, you don't have to worry too much, as I showed in that previous photo, about the Mini Circuit splitter having a low frequency of 10 megahertz. Most commercial gear won't go down below 10 megahertz, so that's why that's just a starting standard figure. But as this series of videos started out with me wanting to see how close a receiver my cheap SDRs was really going to be compared to my 7610, then I was happy to accept the 3 dB loss, and I'll be using that Mini Circuits two-way splitter so that I can TX on my 7610 and receive on both my ICOM and SDR. Now, I don't expect them to be even close. The 7610 is obviously an expensive $5,000 radio with a great receiver in them, and these RTL dongles are $35, designed to receive originally 650 meg television. So, but it's interesting to do some comparisons between the two, and you still get to be able to expand your receivers. You know, the 7610 only offers 2 independent receivers, whereas this you can get 24 independent receivers. So the RTL, this NULEC, is just a great starting point. There's no need to get the top of the line SDR. You can just get one of these and have a bit of a play around and use it in conjunction with SDR console to be able to learn SDRs and just to see how much of a difference it's going to make in your situation. So I mentioned before about the protection that isolation provides. Now, this is where it really matters. So let's take this for an example. These are the specs that are shown on the RX in, RX out. If we take the 50 megahertz, 50 dB of isolation there that we've got as an example, if you're running 100 watts of RF, then how much of that signal is going to get into the front end of your SDR? Well, if we break down the maths, 100 watts is plus 50 dBm. Now, if we take away 50.7 or 51 dBm, then that's going to be equal to -1 dBm. Now, 0 dBm is 1 milliwatt, so your SDR is going to see about 0.79 of a milliwatt out of the SDR switch on 6 meters with 100 watts being transmitted from your radio. So this also doesn't take into account the extra loss that we have in the two-way splitter, but basically it means that you're not going to blow up your SDR. You're going to have the smallest amount of power. These things can handle like up to 10 milliwatts or something, so you've got plenty of headroom there to be able to play with. Now, you will see your TX signal on SDR console, but you can also mute your audio when you transmit, when it sees it as a super strong signal, or add attenuation to the display. The software is really cool in that you can do that. So just a couple more notes. When I showed you my setup earlier, the SDR switch has 4 RCA connectors on the back. The RCAs are used because if you want to do a lot of portable or roving operations and cables break, then RCA cables are very easy to obtain from local stores. You do need to put 12 volts on the back of the RX in, RX out. If the power fails or if you forget to connect it up, then the SDR switch just defaults to the TX path so that it will protect your receiver chain. And all of the SDR switch ranges require the usual ground loop PTT from your radio in order for it to work. None of them come with RF sensing because RF sensing just fails too often and it leads to expensive repair bills when you blow things up. So before you do anything, connect your PTT. Make sure that you can hear the relays click in your SDR switch before you connect everything up. And the easiest way to do that is to select upper sideband or lower sideband on your radio. Don't talk into your mic, but just click the PTT, because then you won't be putting out much or any RF power, and you should hear the relays click inside your SDR switch. Now, I mentioned the amp RCA earlier in my setup. I don't run an amplifier, but this does allow you to key an auxiliary piece of equipment such as your amp from the PTT of your SDR switch. Basically, you plug your amp into this RCA rather than onto the PTT of your radio, so it's just another PTT out. The RX in-out was designed to be able to use with an LNA, so 12 volts does come out of the LNA RCA here. Now, you need to make sure that you don't connect your LNA up. If it runs off 5 volts, you do need a converter like I've got in my setup so that you can convert from 12 volts down. So what this will do is this will provide power when it's receiving normally, and then when you press the PTT and you start to transmit, it takes power off, which then turns off your LNA and protects it. So this is everything all connected. You could see here that I've got my SDR switch connected to the 7610, all running through one antenna. I'm receiving on FT8 on 6 meters, and I'm also receiving here across the entire 6 meter band using my SDR, and I can see everything that's going on. If I see something pop up or hear something pop up on the SSB portion, then I can easily switch my radio to that. Not only that, I can use OmniRig so that I can synchronize everything. I can synchronize my SDR, I can synchronize the software, and I can synchronize my transceiver. And then in that way, if I change frequencies, they all change, and I don't need to worry about changing radios and changing dials all the time. Now, if you want to see more about this particular software, SDR console, or learn more about SDRs in general, then I have got a playlist here of other videos which I've been doing, and as I release these under this series of videos, then they'll be added to in this playlist.